Jonah Berger. So let me get started. I think we can get started. It's already 11:06. So we're going to have this session today about textual analysis and machine learning. Good morning, everyone, wherever you are, and hopefully you're healthy and happy to hear such a great team of speakers here. We were lucky to have the acceptance of Ashlee Humphreys, professor. Let me be more formal, Ashlee, for a while, just to present you. Professor Ashlee Humphreys, Professor Samir Singh, and Professor Jonah Berger. I will get started with a very quick introduction about the subjects that we will be discussing. But of course, our three speakers are world-class researchers on the field of textual analysis and machine learning, and you have much more to learn from them and from me. So I will try not to have that to stop them from teaching us about machine learning and textual analysis. Let me get started with sharing my screen here. Okay, let me see. Hopefully it will work. Okay, can you see my screen, guys?
Yep.
Okay, good. Okay. So these are the participants of today's session. As I have mentioned, Ashlee, she's from Northwestern University. She is an associate professor at Medill School. Very interesting research subjects in consumer behavior and marketing strategy. Please, guys, let me know if I say something wrong and if you want to complement some things that I try to briefly describe your great CVs here. So she is interested on legal and cultural institutions and creating markets. She has very interesting papers at the Journal of Marketing about that. And also the influence on language on consumer judgments of legitimacy and the process of consumer co-creation. I invite the audience to read Ashlee's papers published at the Journal of Marketing, Journal of Consumer Research, Sociology Compass, and her book on social media, Enduring Principles, a very interesting book that Ashlee has published. Jonah is an associate professor of marketing at the Wharton School. He's interested on growth strategy, influence, word of mouth, NLP, viral marketing, and he has many interesting publications in top journals in marketing, in psychology and management. Very interesting books as well. 3 bestseller books, The Catalyst, Contagious, and Invisible Influence. And Ashlee and Jonah are specialists in marketing. And we are also pleased to welcome Samir Singh, a professor, associate professor of computer science at the Donald Brand School of Information and Computer Science at the University of California, Irvine. Samir has his research interests are on robustness and interpretability of machine learning algorithms and also models of NLP. He has received many awards so far and published in many different machine learning and NLP journals, and also in the most important conference of the field. So we have 3 very distinguished researchers in the team. Hopefully we're going to have a very interesting section. We are going to start with, I'm going to talk briefly about an overview of NLP and machine learning, a very brief presentation. Next, Samir will give his perspective on how NLP is evolving in computer science, and also what are, in his opinions, the trends for NLP. So he has a very interesting podcast on the This Week in Machine Learning podcast that he talks about this subject. I invite the audience to hear also his interview on the Twimo podcast. And after, Ashlee is going to talk about automated machine learning methods, and we're going to have questions and answers. And Jonah Berger had a problem to arrive at the beginning of the session. He will probably arrive at 12:30 local time here in Brazil, and he will give his talk on the last 30 minutes of the session. Okay, so what is NLP? What is natural language processing? Very broadly, the goal of NLP is to program computers to process and analyze large amounts of natural language data. And when we talk about NLP, it's a combination of the fields of linguistics, computer science, and AI machine learning. The most challenging aspects of NLP is to work with speech recognition, with natural language understanding. And more recently, we have had many interesting applications of natural language generation from new discoveries like GPT-3, things that I believe our guests will talk about. What we will discuss is related to our daily lives. So NLP is everywhere in our daily lives. We can find it on search engines like Google search engine, search autocorrect and autocomplete services. We have NLP used in language translations, in social media monitoring, in chatbots that sometimes we hate them because they are not so good yet, but they are everywhere. We also have grammar checkers that use NLP. Most of you probably use those grammar checkers to write your papers. We have email filtering for classifying what is a spam, what is not a spam. Also, we have applications of NLP and survey analysis in target advertising, in hire and recruitment. This will be a session for a management conference, so there will be people not only from marketing here, but from also human resource and other fields. And of course, voice systems. The text generation targets, they are more related to, well, there are many different applications coming up in this field of text generation, like CV generation, code generation, conversations. So there are really lots and lots of new interesting things being discovered. But how do we connect natural language processing and machine learning? So very broadly, when we talk about machine learning is the study of algorithms to automatically learn and improve through experience. Of course, with a large use of data, and this is common from NLP and machine learning. And you probably have seen this figure many times. So the broad field is artificial intelligence, and machine learning is a subfield of AI. And deep learning is probably the most used algorithm to study NLP applications into the field of machine learning. Many of the most developed and advanced applications are using the algorithms, some kind of deep learning algorithms. And I believe our guests will talk about it too. Broadly speaking, the three types of machine learning, the most important, there are some authors that include other types, but these usually are the most traditional ones, what we call supervised learning, unsupervised learning, and reinforcement learning. Most of NLP applications are related to these first two types of machine learning, supervised and unsupervised. There are some reinforcement learning applications, but I believe in terms of development so far, the first two ones are more frequent in terms of those applications that we have seen. For those who are not familiar with machine learning, when we talk about supervised learning, what we are trying to do here is to teach a computer based on, for example, in this case here, an image. It can be text, of course, it can be video, it can be anything. And we have a label saying to the computer, look, this is a cat. So the computer will learn what is a cat and what is a not cat, because the computer is only learning what we are teaching. The most common applications of supervised learning are classification, which is used a lot for text purpose, and regression. When we talk about unsupervised learning, we are not necessarily teaching the computer, but we are using the computer, letting the computer classify or group different objects, words, sentence, texts, and so on. So in this case here, we use unsupervised learning mostly for grouping purpose and for classifying, for dimensionality reduction. So classification and dimensionality reduction are the two most frequent use of unsupervised learning. And finally, reinforcement learning is the third group of major applications where we have agents that interact in a specific environment and receive some reward. So this is a very, very broad and starting view about machine learning. And I will open the floor now to our guests to hear their perspective about NLP and machine learning. And we are going to start with Professor Samir Singh. Samir, thank you so much again to have accepted our invitation and be here. I will let you talk about these many different applications here, many things that you work at computer science, and we are extremely happy to hear from you. Thanks again.
Thank you, Vincent.
If you want, I believe you can share your screen. Great. Yes, it's working.
You guys can see my screen?
Yes. Thanks.
Perfect. So today, thanks for the introduction. Today, I'm going to be talking about a bit of a CS perspective on natural language processing. Essentially, what I'll be talking about today is going to be sort of what makes NLP challenging from a computational point of view. Why is it so difficult for machines to deal with NLP? Give a quick sort of overview of how we approach NLP problems from a machine learning perspective, and how can we even apply machine learning, and why do we apply machine learning? Give a quick higher level sort of view of what the recent progress in NLP has been in the past decade or so, and then sort of talk about whether it is actually solved and to what degree, what are the main issues that remain. So let's actually get started with what makes NLP challenging. So there are three things that I'm going to talk about fairly quickly, which make it pretty difficult for machines to handle NLP. Their ambiguity, sparsity, and variation. And I'll kind of give examples of these, and hopefully through examples, you get a good idea of why it's kind of difficult. So let's get started with the first one, which is ambiguity in language and how that can be very difficult for machines to handle. Language by definition is ambiguous, and you might be wondering why it is ambiguous by definition. There is this nice maxim of quantity that I like from Greasy, which says that one tries to be as informative as one possibly can when you're communicating to someone. You try to be as informative and give as much information as needed and no more. Okay? And this no more is the really crucial part when it comes to computer science. The other way to think about this is the more the listener knows, the less they need to hear. Right? So when I'm telling you something, I have some shared model of sort of what you know and what I know. And so I only try to tell you something that you don't know. When you start thinking about computers being the listener, or the computers trying to generate language, that's where it becomes really difficult, because they don't really have the same shared model. They may not know how the world works. They may not have lived the way we have lived our lives. And so by knowing very little, to have no ambiguity, they need to be told a lot. So I'll give you a few examples, and some of them will seem really simple. Some of them are kind of difficult, even for humans to parse. And so you can imagine if computers who don't have the world knowledge, how they can actually even do it. The biggest problem is, one of the underlying problems is that words have many meanings. So I can give you a really simple sentence. This has some of the most common words in English. He knows you like your mother. Even this simple sentence, which has very common words, actually has two completely different meanings, and making it very ambiguous. And so in some context, they might make sense. One meaning is that person, he, knows you the way your mother knows you, right? So however much your mother knows you, that's how much he knows you. And the other one is just that he knows that you like your mother. Really common words, but even then there is a lot of ambiguity in what it is. A lot of this comes from context, comes from common sense about how the world works. So here's an example that I like, where it's clearly common sense, but you can use it for humorous effect. So here's a sentence. One morning, I shot an elephant in my pajamas. How he got into my pajamas, I'll never know. right? And clearly, this is funny because you assume when you read it first that in my pajamas is talking about me when I'm shooting the elephant. But yeah. In general, to understand language, you need to know how the word works. Here's a sort of very specific example of how this kind of ends up working. I'm giving you two sentences here. The city councilman refused the demonstrators a permit because they feared violence, versus the city councilman refused the demonstrators a permit because they advocated violence. Almost the same sentence. There is only one change, feared versus advocated. But because of this change of this word, what is the word they referring to, the one right before feared and advocated? Turns out in the first sentences, it's the city councilmen, because they're the ones who would fear violence. And in the second example, it's the demonstrators, because they would, according to the author, they're more likely to advocate violence than the city councilmen, right? And so to be able to do this, you kind of need to know a lot about what kind of people city councilmen are, what they care about, what is their job, what do they have to prevent, demonstrators, what are they likely to do, things like that, right? And so all of this context becomes really important. It's somewhat trivial to us sometimes, but not so much when you're thinking about it from a computer science perspective. Here's another example when you need to know how the world works. If your dog does a poo, please put it in a litter bin. So clearly, this person is putting the dog in the litter bin. So these were just some simple examples of ambiguity. It gets a lot more richer than that. The other thing I'll talk briefly about is sparsity of data in some sense. I'm going to be a little bit quantitative here, but hopefully you get an idea. So what you can do is, this is a plot I'm showing you of the most common words in a large English corpus, right? So you take all of the words that appear. I think these are on a bunch of books, English books, and you take the most common words and you see how many times they appear, and then you rank them. So this is the rank, goes from 1 to 100,000, and this is how often the words appear. And now you might be waiting for me to actually show you the plot, but actually the plot is already there. You can't really see it. There are these dots all the way vertical here and lots of dots all the way horizontal. What this really means is more than 1/3 of the words appear only once in this corpus. And there are other words that are way, way, way more frequent compared to the rest of the words, right? So you can see the very common words appearing here. And the problem is, it's not just that the important words appear a lot and rare words are not important. A lot of words that appear in this just once are the kind of ones that we might care about. There are also words that are a little bit complicated that we still care about. And then there are a bunch of words that maybe there are typos or things that we don't care about, right? And that's the problem. Like, there are a lot of words that we care about that are very rare, right? The other way to look at this actually is to rescale the axis by doing a log scale. And then it sort of starts looking like a line. The most frequent ones appear way more often than the rare ones. This is called the Zipf's law. And what basically this means is that regardless of the size of the data, it doesn't matter how much data you give it, there will always be rare words. That's kind of a problem with like computational stuff, because you hope when you have a lot of data, you will know everything. I want to say that this is not specific to English. In fact, this kind of trend you can see across many different languages. So I don't have Portuguese on here, but you have English, Spanish, German, Finnish, and so on. Okay. The last thing that makes it difficult, we're still not through all of the challenging aspects of NLP, it's just the amount of variation we have in language. So here are some examples of sentences that kind of mean the same thing, but they look very different from each other. So in the first one, she gave the book to Tom. She's giving the book to Tom. Whereas the second says she gave Tom the book. We've kind of reversed the order of words, but it still means the same thing. Some kids popped by versus a few children visited. They mean the same thing, even though there is no common word between these two. Is that window still open? Sounds like a question, but what it basically means is please close the window. And so if you say, is that window still open? The computer might say, oh, yes, it is, and not do anything about it if it doesn't really understand what's going on. The other thing I like about language is how much variation there can be in what even is an input sentence. So here's a sentence from Great Gatsby. This is the first sentence of that novel, and we don't have the time to read it, but you can see this is a beautiful sentence. But you can also go on Twitter and find a sentence that's also beautiful in a different way, I guess. But when you expect computer science to do NLP, you expect it to do both of these, which is quite challenging. All right, so let me quickly go over how we even approach this difficult challenge of dealing with NLP. Essentially, there can be two approaches when you think about NLP. And the more traditional one that's, before 30 years ago or so, was to directly use linguistics, try to come up with rules of how to take a piece of text and understand it. It can be expensive, it can be time consuming, but turns out that it's also usually incomplete. You can't specify, you can't do everything very robustly. On the other hand, you have the machine learning aspect, where you try not to use too much linguistics, but you give it a lot of data and you automatically learn what's going on. And the tricky thing with machine learning is the right data has to exist, otherwise it doesn't kind of work. There's this interesting quote that Fred Jelinek had: every time I fire a linguist, my accuracy goes up because you rely more on data. The way machine learning works is to take NLP, which seems like a really difficult problem, and break it into simpler tasks. So you can take any input like this, you give it to a machine learning model, and then you only focus on one aspect of this that you care about, right? So for example, is this a positive sentiment or a negative sentiment? Is this spam or is it not spam, and so on, right? Like this is a single label you care about and you only focus on that. The other idea is to sort of extract things from this piece of text. My trip to Rio was really awesome. So, okay, this person is going to Rio and Rio is a city, things like that. You can also generate sequence of words such as dialogues and things like that. If one person says my trip to Rio was really awesome, the computer should say, oh, how long were you there? And so on. And so the idea is you break it into these simpler tasks, and then you essentially train machine learning model for the specific tasks. So you get some examples of input text, like tweets or whatever it is, some examples of output, which say positive or negative. You send them both to some machine learning model. They do some complex math that involves deep learning and all of these things now. It gives you a classifier that can take some new input text and predict the output. So I'll quickly give an example of how this looks like for something that sounds very difficult. This example is going to be machine translation, and it's going to be Spanish to English machine translation. And I'm going to say how computationally we can even approach it. Right? So here's the sentence that we need to translate to English. I'm not even going to try to pronounce it. But the first task, this is a machine learning task or an algorithmic task, is to break it into pieces. These are called chunks because these are not really words, but these are phrases that we think we can translate. That's a machine learning problem. The second machine learning problem is to decide what the possible translation of each of these phrases is. So you can just look up a dictionary essentially, and you can list all possible translations, right? And any combination of these words is a specific sentence, but right now we're talking about independently how to translate them. Then we can start putting the translation together in an order, right? So now we can take paths through that and create all of these sentences, sometimes in the same order, sometimes in a different order, right? This is also a machine learning sort of problem of how to do this. And finally, we can take these sentences and we can decide which one sounds most natural or most human. If you did look at some of these kind of seem really, really random, or at least not grammatical. So I try to leave for the most lovely open space. That clearly sounds not human. I want to go to the prettiest beach, definitely sounds good. So this is a machine learning problem of figuring out what sounds better, and then you get your translation. Okay, so with that, I'm gonna talk about that's sort of how machine learning is applied to NLP. I'll give a quick higher level view of what's been happening in NLP recently that has made it so important. Turns out now NLP is actually really, really good. In the past decade, we've made impressive advances. And essentially, it's because of this simple idea that has been growing and growing over the years. The way I describe machine learning applied to NLP was to take a single task, like understanding the sentiment of our input. My trip to Rio was awesome is a positive sentiment, as a way to train a machine learning model. So you're training one machine learning model just for sentiment. Around the turn of the century, around like 2010, I would say, one thing that started becoming popular in NLP was to say, okay, why are we training a different machine learning model for every task we are doing? Why don't we try to do something that is just looking at text and trying to understand it? And so around 2011 or so, the first idea sort of started sprouting of just reading the text. So you give it all of Wikipedia and you don't tell it, hey, predict sentiment, and you don't have to label data, nothing. You just give it Wikipedia and you say, just read it. And you come up with an algorithm that just keeps looking at that text and trying to understand what the words mean. Right? And then whatever you learn, then you use machine learning on top of that. So even the reading part is machine learning, but they sort of differ in what their goal is. The goal of the second model is to learn sentiment. The goal of the first model is just to understand English. Right? And that seemed to work quite well. And then what started happening was people started to make this reading part bigger. So then the model started looking a lot more like this, where the reading and the machine learning part sort of started becoming equal in size. And people also started giving more and more data. So not just Wikipedia, read news, read some of the popular websites like Reddit and so on, right? And this reading part, just understanding English, started becoming bigger. As we come closer to present day, we are sort of in this stage where this reading part is getting much, much, much bigger than the machine learning for the task, specific to the task. And so we are doing this general purpose reading rather than task-specific reading. And we're trying to give it as much text as is possible, right? So everything that's publicly available, for example. And if you think about the future of NLP, this whole reading part is going to become bigger and bigger and bigger, and it already is. And we're trying to give it any digital text that's possible at all. And the task-specific machine learning, just predicting sentiment and stuff, is becoming really, really narrow. And then these models are so big at this point that not only do they not fit on my watch or on my phone, they don't even fit on my laptop. They don't even fit on most desktops. They can only fit on large clusters that universities usually don't have. Okay. So what has this resulted in? This is an example of a glue leaderboard that has many, many tasks. I think there are 9 tasks here. You can see these are the different columns. And these are different NLP models that people are working on that are listed there. And this is their performance. And you might be like, okay, some of them are 70, some of them are 90. Like, why is this important? Turns out the humans are at number 9 on this leaderboard, right? So all of these 8 models, machine learning models, are already better than humans on all of these tasks, right? There are like 9 or 10 tasks. Humans are not doing that well. So already NLP is better than humans, I guess. So once they did that, they came up with this super glue, which was supposed to be even more harder and more difficult. And the screenshots are actually old, so humans are much worse now. But even in this one, humans are at number 3, and there are already models that are doing better than humans on these new tasks, right? These are tasks that are supposed to test NLP, right? And so maybe at this point, we should just pat ourselves on the back and be happy that we've solved NLP. That's kind of, if you look at media, these are articles that are pretty old at this point, but even like 3 or 4 years ago, people were talking about how AI models are beating humans in terms of reading and NLP stuff. Okay, so finally, the question is, well, is it really solved? Turns out that it is not. The problem is that NLP can fail in very unpredictable ways. So if I just say, I didn't like the flight, many of the models actually think that's a positive sentiment. Because there was a word like in it, right? So even the latest sentiment analysis system don't really understand that this negation. Here's another example. I can't lose my luggage. I'm moving to Brazil. That's a neutral statement, which you might argue is correct. But if I change it to I can't lose my luggage, I'm moving to Turkey, this the model thinks is a negative statement. Why it changes, it shouldn't change the sentiment of the sentence. It's the same sentence, but it does, right? Here's another example. You can start with a sentence, American Air service wasn't great. The model will give you some sentiment about it. You can add, you are lame to that sentence. And the model actually thinks that this is a more positive sentence, which is not great. So these are sort of practically some of the biggest problems in NLP. The other way to think about this is also these NLP models, since they're reading so much, they who knows what they actually take out of that text, and the text can contain all kinds of ethically problematic behavior. So that means the NLP systems also often have ethically problematic behavior. If you just let them generate text, they can generate text that's extremely sexist. They can generate text that's extremely racist. And in general, they generate text that's extremely toxic as well, right? So we want systems that are able to read English language and any language and be able to capture that. And the biggest downside with that is that they capture the worst of the things we have out there as well as the best. And that can be very problematic, right? The worst of the people out there is pretty bad. With that, I want to wrap up and thank you for your attention.
Thank you, Samir. Thank you so much. So let me thank you for the very inspiring talk. We have some questions here in the chat, but I'm not sure how we're going to be in terms of time available at the end. We will definitely have some questions and answer space, but I think it would be better to jump in into Ashlee's talk. Then probably before Jonah's talk, we're going to have some time to question and answer. So I will take notes here, and they are also in the chat. I invite everyone in the audience to make questions there if you want to. Our guests will be pleased to answer, I believe. Ashlee, please, the floor is yours. Thank you again.
Great. Yeah, thank you. Hi, everyone. So it's really nice to be here with you today. And it's a very interesting speaker order because I feel like I should have gone maybe right before Samir, because we really have two complementary but very contrasting perspectives, him coming from CS and I'm coming from really a social science perspective. And so I would probably be one of the linguists who got fired when they're trying to increase accuracy. That's me. So hi, everyone. I'm Ashlee Humphreys. I'm an associate professor at Northwestern University. And as I said, I really come to text as a social scientist wanting to study text and incorporate it into a lot of the knowledge and constructs that we have in social science. And I'll tell you a little bit about what that means in a minute. We'll do maybe just some thinking and some examples. So, you know, and again, too, I have approached this from a beginner's perspective. So what you'll see that I prepared for us, because I think workshop was in the title, is kind of the bookends of what Samir talked about. How do you set up a research design and think about incorporating text into your research? And then once you've done the magic, the back end, how do you address issues of validity and accuracy, external validity and all that? So that's what I'll focus on today in really my brief time. And I think I have 30 minutes, is that right? Great.
Right. We are quite flexible, I would say,
okay.
Ashlee. So feel free if you want.
Okay.
If you
yeah,
need
no worries.
More time.
Yeah, that sounds good.
Okay.
I'll try to compress a little bit, but this may be a little fast. There's a lot to cover. But okay, so you know, we think that data looks like this, that it's like ones and zeros, and it's all pretty and in columns. And of course, as Samir's talk highlighted very nicely, that's not what data looks like. Data can also be unstructured, can contain ambiguity and variety and all of these things. It kind of looks like this, and particularly text that we might want to study to understand marketing issues, like reviews that you see for this Google Nest camera on the left, or media text that you see up at the top about what Apple's company actions, or text that you see on your bottom right from Twitter, where the brand is putting out communications. These are all great types of data to learn about companies and customers. But the real question for us, at least as management scholars, what do we do with this? Particularly if we don't have the skills of a computer scientist, what do we do? And I mean, part of what I try to bring to people is that there's a lot of different roles for understanding this data, and it's great to be very sophisticated and have a great tool set, but I don't want people to feel intimidated that they cannot themselves do some work in text analysis. You too, anyone can count words basically and use computers to count words in order to learn something about the world. So what could we learn from this text analysis, from this data? I think on the left from the reviews, maybe we could learn about what customers are expecting in terms of privacy. So a lot of these reviews are talking about how their Nest Cam might be connected with the internet, might be broadcasting pictures from their home. What can we learn about consumers' expectations of privacy, how that impacts how they rate the camera, things like that. At the top from Apple, we could learn something about how the portrayal of the company has changed in the media. How has corporate action changed that perception with media as the dependent variable? And then from tweets, we could learn something about the relationship of text with something that happens outside of the world, like stock price, right? And there's been some very interesting work that shows relationships between what happens on Twitter and changes in stock price, for instance. I'm thinking here, if anybody's interested in this paper by Jerry Tellis and colleagues that does Chatter Matter, where you see that the volume of online tweets impacts the stock price. However, what's interesting, so that paper is now quite old, and what's apparently very interesting is that relationship itself has now changed now that people know that this exists. So it's a very complicated social system when we're studying text. But there's a huge amount of textual data, and we tend to think of things like online reviews coming from marketing and from management. We tend to think of online reviews and social media posts as marketers, but there's actually a much larger world if we think about not only consumers talking to firms or to other consumers, as in these boxes, but also a huge world of media data, where firms are talking to society at large, where government reports and congressional discussions are batting around important ideas. There's a lot of text to study. And so I guess my role is to help you feel a little more empowered to study it, even if you have not mastered the toolkit, okay? So I'll take you through a little bit of process in addition to this motivation. All right, so how do you approach this? And again, I'm talking mostly to people who've never thought of doing this before and who want to learn something from that kind of text. The first and of course, really important step is to create a good research question that is actually appropriate for studying text, that identifies constructs that can be reflected in text. So thinking about some of those issues that Samir mentioned of ambiguity and variety, finding where those constructs live. So actually collecting the data through web scraping or other tools. That's kind of the second step. And of course, what we never talk about is the elaborate cleaning process that has to take place for your data. I'm also not going to talk about that. I'm just going to say it takes a long time. The step 3 is really to choose a method. And I'll talk about a few different methods. We're lucky that both the speakers have already given a very nice overview of some of the methods available. I'm going to talk a little bit about just dictionary-based analysis, where you develop a list of keywords and go and count them. I'll talk about that in a moment. So step 4, you basically use a program to analyze the data, to count the words, then you interpret the data and validate the analysis. So that's kind of what it looks like from a social science perspective. If you're coming at this for the first time, a similar process happens if you come from more of a CS or data mining perspective, where you think of the data more as you need to pre-process it. You need to tokenize it, which means kind of label it and split it up in particular ways. There are some slight differences in procedure, but essentially it's the same workflow. You know, there's a data pre-processing stage, an analysis stage, a measurement stage, and validation. And I guess the only thing I would say in terms of other kind of differences is sometimes the research task is a little different depending on where you're coming, what your goals are. So from a social science perspective, it tends to be that you have a theoretical idea or construct that you care about, like privacy or risk or trust, something that we know a lot about from previous research. And text analysis lives in kind of the middle of this process. And then you want to get some insights out of it on the other side of the process. Whereas from more of a machine learning or data science perspective, that text analysis piece becomes more the point of the research in terms of we want to produce the most accurate predictions possible, right? We want to tackle new problems in terms of weird kinds of text. Can we get better in predicting those? So the kind of goals of the research can be a little bit different, but I think you'll see how they kind of feed off of each other, because of course, the more accurate we can be, the better we can be at studying privacy or any of those other things. Okay. So the speakers did a very nice job of laying out classification approaches where we have a trained labeled data set and we feed that into a computer, and the computer tells us, okay, these are the words that indicate group A and these are the words that indicate group B. We also have these unsupervised methods where we feed in a big lump of text and the computer will identify it for us. This is group A and this is group B. So I would call those both bottom-up processes in the sense that you're having the machine do a lot of the conceptual work, basically. I also want to add into the mix dictionary-based approaches, which are not as accurate. I think that's quite clear, but they can be really nicely aligned with theory. So for instance, you know, if I'm studying privacy in these text reviews, I can already read through with my own brain the text and provide a word list or a topic list of how I might measure privacy. And that's often a great place to start with the analysis if you've never done this before. And so I can make my word list of words about privacy, and then I can go ahead and run that in the count the words in the computer and see, do those words correlate with a high rating or a low rating or whatever, right? So it's a good first approach to use if you have never done this kind of work before. All right. I won't get into too much detail. I'll just let you, sorry, this is in a JCR paper. There's kind of a series of questions to start asking yourself as you go through the process. And it really has to do with lining up. Do you know the constructs a priori? Do you know that you're studying trust or privacy? Or do you only have a vague sense of the constructs, right? If you kind of going in know what you sort of want to measure, it's helpful to go ahead and just start measuring that rather than to have the data tell you about itself, because often what happens is when you use a completely unsupervised approach, you're going to get 5 topics, and those topics may not contain what you're interested in. They might be very concrete data level things like the service at the restaurant or the food. And of course you have to label these. So you're just going to get these groups of words. And then you'll have to kind of wrangle those groups of words into more theoretical topics. Whereas if you start with a kind of a theoretical idea coming in, you can absolutely sometimes get more out of it if you just start counting those words, right? And it just is valid. Those live in the data, but they may not be like the most common or top or popular words in the data, right? Okay, so, and yeah, Carla, I see your question. I will try to answer that in the question session. Okay, So just to give you an example of how this lines up with something like psychological research, you could take a look at product reviews and ask, do experts respond differently from non-experts to a product launch? So here you're just comparing two groups and you want to have a measurement of differences in response, maybe according to using more cognitive language or talking more about features or whatever. And so here I'm making predictions, again, kind of according to the social science of it, of like, I'm making predictions, having hypotheses prior to examining the data. And of course, it can be an iterative process, but social scientists tend to start with like, here's the hypothesis. I don't have too much time to integrate linguistic theory, although I did love Samir's shout out to Grice. Just in thinking about research questions, there's a great history of thought on what we can learn about language and through language to draw from. So text, in thinking of a research question, you can use text to reflect intentions or actions, working from speech act theory. And there's just a great theoretical apparatus for seeing how language can differ. Are you making an assertion, or giving a directive, or making a commitment or a declaration? All of these have slightly different meanings that can really have an impact on things like product reviews, for instance. There's this JCR paper about that. It can represent things like my mindset. Am I thinking about an event or a person as close to me here, concrete now, or very far away? All of those differences are reflected in language. And so you can use text to reflect a mindset or an orientation or something like that. Another way to use text is to reflect relationships or context. So this is work drawing from semantics and the idea that we have cognitive maps of things like brands. There's a great paper on brand positioning that uses text data, where you can see, okay, based on co-occurrence, when I talk about a car like Honda, I will also tend to mention in a message word a car like Toyota. And we can use text in that way, those co-occurrences, to make a market map, right? That says, okay, the Honda is a lot like Toyota, and it's very different from a car like Cadillac. So text can be very good for kind of mapping those cognitive relationships that live in people's heads, but also kind of live in culture, right? And then a final way to think about text in your research design is that text can generate impact. And here this draws from the work on framing, linguistic framing. So for instance, I guess in my own work, calling an industry casino gambling has a very different impact on the way people perceive it than gaming, right? And so you can start to study those linguistic differences in other things in the world, like legitimacy or stock price or sharing behavior, things like that. All right, so I'm just trying to stoke your interest a little bit for creating some good research questions. Again, I don't know how expert the audience is, so I'll just kind of briefly go through step 2 and give you a few good links and tools that you may not know exist. So to collect the data, obviously you can use web scraping, and there are a lot of good point and click tools now for just getting data from any web source. Of course, RVest is a great tool if you're doing R. There are lots of other places, databases to get text. After you get it, you're going to want to organize it in some way. Again, I know this is workbench stuff, but it's a key part of the process that you might be surprised at. The way that I approach it is, of course, you could create an Excel data set if your text is relatively short, but that may not always be the case. So, I work with media data where you have a long newspaper article. You might need to create a text file for each of those. Again, I'm speaking mostly to the kind of the social scientists who aren't going to create a big database or something. Yeah, so basically you need to get your data into a structure, and I'll show you exactly how you would then analyze it in just a moment. Other data sets are available. There's a great site called Kaggle.com. I don't know if anybody's on, but has a large amount of data that you can use and analyze for free. And much of it is market related. I got a great data set of hotel reviews. There's a nice data set of clothing. I mean, if you're looking for data, it's pretty nice. All right, so you'll clean the data, and typically it will look like this, just to give you a sense of what you're doing. This comes from Amazon, of course, where you have a non-textual variable like the rating, the title, the date, don't know what that is, the user, location, and then the comment. And so if you're using a program, well, I'll show you in a moment, but if you're using, say, a dictionary-based program, what you're going to do is tell the program, okay, analyze this column, the comment right here. And then the program will count the words for you and give you numbers there. Okay. In terms of tools to use, I wanted to kind of cover the breadth for the intros. I use something called Luke, and probably Jonah will talk a little bit about Luke. I know he uses that a lot. It's developed by a psychologist named Jamie Pennebaker to really measure some basic psychological constructs. So a lot of what was done there is to put in existing measurements of emotion, for example, of what else? Past, present language, stuff like that. It offers a nice, robust set of dictionaries that you can use to measure a number of linguistic categories and social categories. So there are categories for friends or family, social words, money words, religion. It's a nice place to start if you haven't done this work before, because it has a set of built-in word lists or dictionaries. Now, of course, after you run your data, there's a few very important validation steps that you need to take to make sure that what has been counted is actually a true measurement of that construct. But it's a great place to start. So I'd highly recommend starting there. I think it's like $10, to buy or something. Obviously you can use our account works as well. You can also do bottom-up methods, classification, even without programming. So for ease, I've been using this program called WordStat that you can, it's Provalis research. If you're looking it up, just look up WordStat. It will do a topic model for you or a classification that's a point and click method, and you don't need to code, which is great. It can do some very sophisticated things, just pointing and clicking. WordStat is also very good for dictionary management. If you want to then, let's say, work back and forth between a topic model and dictionary. So for instance, you can analyze your data to get a set of topics with the words. Then you can save that as a dictionary, a word list, and go on and continue to refine. So it's a very easy tool for kind of working back and forth between these approaches, because of course there's no one, best approach. It's really just about systematizing and learning about your data. Okay, so step 3, and here I'm gonna fill out the dictionary approach a little bit for anybody who's interested. It's also kind of the easiest to start out with. So the first thing you want to do is to look for a standard dictionary that measures your construct. That's the best, kind of place to start, because it makes the publication process much easier, right? So if there are existing dictionaries, and I'll show you some examples in a moment, you want to at least try to run those through your data. Even better if there are one or more dictionaries to use to analyze from your construct to analyze your data. Then you can start triangulating and developing a sense for, internal validity. That is, have you measured privacy the right way? You can run 2 privacy dictionaries. If they correlate, okay, you know that you got something there. All right, so assuming that you may not have a standard dictionary for your construct, you can construct a custom dictionary. And I can't over stress enough the importance of reading some of your data first, of understanding actually what's there. I'd say regardless of the approach, not enough people actually understand what the words are in their data and how those might reflect the construct, right? So I'd suggest pull a randomized subset, approximately, I don't know, 10 to 20% of your data. It depends on how big your data is, but let's say a few hundred units that you can qualitatively read through. And if you're using dictionary-based analysis, you can create a word list for each concept, remembering things like word stems, common ambiguities, things like that. Then there is a procedure to have people check and refine your dictionary. So essentially how it works is you send your word list to a minimum of 3 coders for your dictionary, and they agree or disagree with including it in the dictionary. And if 2 or 3 of them agree, then you keep it in. If 2 or 3 say kick it out. Pretty straightforward method for at least doing a preliminary validation of your word list. You can see in other articles that there are lots of standardized dictionaries, and I've tried to provide a little bit of a clearinghouse for them. There's dictionaries for looking at brand authenticity, for instance, brand personality, those 5 traits of brand personality, something like concreteness or construal level. So do people think about things as here and now or far away and later? I mean, the list goes on, but standardized dictionaries are very helpful, I think, for matching up with at least theoretical constructs in social science. All right. And feel free to email me if you want to know if there's a standardized dictionary. I'm happy to help you find one. They kind of would be represented like this. So this will just give you a sense of the Luke dictionary categories in terms of number of words to measure cognitive things like, do people use insight words, think, know, believe? Okay, there's about 195 words in that dictionary. And these have been run through different sets of data to kind of expand and contract the word list accordingly. Are they perfect from a computer science perspective? No, definitely not. But they're a good place to start. And on the whole, they give you a pretty good measurement. Okay. So then you run the analysis. I just again wanted to give you a visual of what this looks like. If you're using Luke, something like Luke, for instance, you might identify all of your text files here, or you might now, Luke, you just put in an Excel file and identify the column that you want analyzed, and then you get output. Your data would look like this. And so you're going to get something like word count here. Each line is one post, one review. It will give you the word count. So there are 99 words in the first post, and then a percent of words about that topic in the post. Okay. So one thing you might notice is there are a lot of zeros, right? You have to remember things like Zipf's law and the fact that, like, if you're only looking for 1 or 2 words, you're going to get a lot of zeros in your data set. Right. And that's fine. There's some signal there. But you have to keep in mind that you can't use, our typical parametric methods because it's not normally distributed. So just a heads up there. Yeah. So what you get here is a percent of all the words. So 1% of words in this post, 1% of these 383 words are about aesthetics, right? Looks, cool, whatever. And so then you take this sheet that you get and put it in whatever statistics package you prefer. All right. Now, in terms of interpreting and analyzing the data, the kind of first measure you get is typically the percent of words in the article or post to control, of course, for long posts or short posts, etc. But there are other things to address if you want to get more sophisticated, like the term frequency. So as Samir mentioned, about, 80% of words in our language are very, very common words, right? Only when you get out on that long tail do you see words that might actually have more meaning. So like the most common words might be is, the, of, etc. And so you want to take some account of frequency there. So if you have a very frequent word, it may not mean much, right? So you do measures like TF-IDF to account for total frequency in the document itself. Yeah, others have used things like if you want a measure of net emotion, you can take positive emotion and subtract negative emotion to get net emotion within the post, right? These are very rough metrics that will give you a holistic sense of what's the emotion in a post for example, okay? And then you'll want to think not only about like the basic metrics that you want, but also what are you doing in terms of research design? So are you comparing two groups of people? For that, you might use test for comparison, again, keeping in mind that your data is not normal. Or are you looking for just correlations? When people mention privacy, in NESCAM reviews, they also mention friends and family. Is that who they're worried about, right? Then you can start to look for these kinds of correlations, probably using a number and comparing a number of measures of similarity. Cosine similarity tends to be a commonly used one. Okay. So you'll have your suite of measures. I want to spend just a moment in the brief time I have left to talk about validity. Once you have these measures, you need to figure out, are they right? Okay, considering issues of internal and external validity. So is the text accurately measuring the construct? For this, you can say pull out. So let's say, for example, you were analyzing privacy. Pull out 10 to 20 examples where you have coded, where the computer has counted privacy. Do a check of those. Or do those actually tend to be mentioning privacy? And you should have a hit rate of about 80% at least, okay? If you don't, go back, refine the dictionary. You want to ask yourself, is the measurement congruent with other operationalizations of the construct? So can you find 2 dictionaries about privacy or 2 dictionaries about authenticity and compare those? That I think is a very important step, particularly it will help you in the review process, right? Because reviewers, I think, will trust a little more that you are measuring something that's not just dependent on the way you have measured it. You don't have measurement bias, right? Also thinking about discriminant validity. So has what you've measured, is that discriminant from different constructs? So is privacy different from risk? You can run a privacy dictionary and a risk dictionary and show, okay, no, these are not correlated. Okay. So just thinking of internal validity, then you want to start to think about external validity. So are these generalizable? And here there's a bit of a trade-off where if you go for something like a dictionary-based analysis, looking at big construct like privacy, it's a little bit easier to generalize because you can relate to all the other work that has studied privacy. If you go for a more bottom-up method, like a topic analysis or classification, it can be a little harder to generalize the exact categories that you've looked at, right? Because they're data dependent. So if you've just done a topic model of hotel reviews, you've trained your conceptual framework on that data. And so there's a little extra work that you have to do to see, okay, how are the findings here based on this conceptual model exportable to another context? Okay. So I've included these and I'm happy to share the slides if you want to do a checklist of how you're doing on validity. It's a good resource. It's available in this JM article on text. And then lastly, you just write the report, then you're done. Once you know your results are valid, then you're good to go. So that's all I have on my end. I'm happy to take questions at the end or whatever you like, Brei.
Thank you so much, Ashlee. Thank you. Great talk too. It was excellent to hear your perspective about the method. It was really great. So we have we have several questions here in the chat. Let me get started with the questions and answers before Jonah arrival. hopefully he will be with us in maybe 15 to 20 minutes to give his talk. But let me ask you guys first. It's a very broad general question, and I will make this question because we have many students in the audience. If you were a first-year PhD student today, and you had to invest your time and try to build a good PhD dissertation, what are the hot topics, and what are the interesting things that are probably will be hot topics in 2, 3, 5 years? And this question will probably, the answer will be probably very different from marketing, a marketing faculty like Ashlee, and a CS faculty like Samir. And I'm curious about to hear your perspectives about marketing, hot topics for NLP, and CS hot topics for NLP for the several in the next years.
I mean, I can give you what first occurred to me, but it's based on what I'm seeing now. So I don't know if it's, I don't have a crystal ball, but I am seeing a lot of people studying methods for predicting misinformation and accuracy of information in news, in reviews, and other things. A lot of work going on there, not only using automated methods, but also trying to incorporate social feedback into that process for flagging misinformation.
I would say probably the two directions I guess I'm most excited about, but also hopefully are going to be hot. The first one is sort of, the way to think about it is few shot or personalized NLP, where if there are, I think we've been sort of thinking of NLP tasks as these big things that do sentiment for all the tweets and stuff like that, but making NLP something that just works for me individually. Like I have my email and I want just to be sorted in a certain order that might be very different from someone else. Being able to quickly do those kind of things is something where NLP definitely is headed. And I think in general, we've sort of touched where question answering and dialogue sort of how useful it is, but I think there is a lot of scope for having machines that understand language and are able to respond, whether it's customer support or any of these kind of things where humans are involved. And a lot of it can be dialogue-based, which is kind of exciting.
Thanks. Let me address some of the audience questions. Let me start with Gustavo Ferrati's question. He asked, how do we train a ML model to recognize what sounds human or not?
Yeah, so that's a good question. I think the way to think about this is, at least the way the models are right now, is they're just looking at a lot of text that's already out there, and just looking at sentences that are out there. And so they build an internal model for which sequence of words fits into what they think of as English language and which sentences of, which sequences of words don't. And that sort of becomes a scoring mechanism. So there are machine learning models that can say, okay, this sequence of words is very, very natural. This another sequence of word is not. And just, I mean, even the example I gave, you can yourself look at pairs of words and see, okay, how likely is each word to follow the previous one? And just that counting based way of modeling, which is very simplistic way, already would work quite well.
Thanks. Also, Gustavo also asked, what kind of NLP activities algorithms outperform human abilities? Just synthetic tasks or even discursive ones?
That's a good question. I think the tricky thing, and this is a qualification for when I say they outperform human stuff, is they outperform humans in the way we've been testing it, which is not comprehensive. It's not, like you can't just assume that on an actual application, they would do better than humans. It's just the way the data has been gathered and the way the evaluation is taking place. I don't want to say they are flawed, but they are very limited in scope. And machine learning is able to find shortcuts to look good in that evaluation. So that's what I mean when I say they're better than humans. So I think for very ones that do not require much language understanding. I think sentiment analysis is an example where, most of the instances are ones that are just are easy to guess the sentiment of because they're syntactic and not very contextual. It works. But for any of these NLP tasks, like even if it sounds simple, like sentiment, you can always sort of create instances that humans will be able to do well on because it relies on word knowledge or some kind of language structure that models may not be able to do. So, yeah.
Carla Marcolin, she asked, I'd like to hear the professors about unsupervised models and research opportunities connecting NLP and management research.
Yeah, I could take that one. So, NLP actually has a pretty long history in management research itself in terms of dictionary-based methods for looking at annual reports, CSR reports, all kinds of things, speech of CEOs. There's a long history of using supervised methods there. But I take Carla's question to really be about unsupervised methods, and maybe others can think of examples. The one paper that comes to mind is actually not in management, but it's in sociology. An interesting paper where they do a topic model of organizational memos and other documents from the Fed, the Federal Reserve, to look at how organizational attention changes, depending in this case on economic crisis. So I think there is some management research doing to these topic models to look at organizational attention, just as an example. And I'm happy, Carla, send me an email or something and I'll send you a reference to that paper and any others that you might be interested in.
The next question I think will be also for Ashlee. I feel that sometimes it's hard to publish in management with NLP due to the lack of method popularity. Mm-hmm. Like it's not a regression model or something.
Yeah, in my experience, it's all about the reviewers, about suggesting good reviewers who do this type of research and understand it. And then having an editor that understands, oh, for this paper, we need to assign it to this set of reviewers. And luckily, that set of reviewers is growing. Again, if you have a specific paper, send me an email and I can make some suggestions on good people to review it. I'll throw out a few names. Well, one name that I'm thinking of in terms of people who do this in management is Klaus Weber at Northwestern, does text analysis. And I'm sure if you look up his name, you can see his co-authors and start understanding, who would be the reviewers to ask if you have a management paper about text.
Thank you. Let me see what else. Oh, okay. Does NLP address properly pragmatic issues, or the researcher needs to do that integration between text and context?
I'm taking that one for me. I don't know. Samir, do you have thoughts on that one?
No, go ahead. Yeah.
So does NLP address pragmatic issues? I might need to know a little bit more from Gustavo about the question about the integration of text and context. I will say this, just coming from a communication studies perspective, is that it's important to understand the genre of the text that you're working with. So what's the source? What are the norms of language in that source? And am I using kind of a model or a dictionary that was trained using that source? So, the way people use language in a media text, a news article, can be very different from spoken language. And so, I don't know if this answers your question, but it's pretty important to understand that, first you need to understand it within the genre and collect those findings before you start comparing it to other genres of text.
I guess I can add that, yeah, from a computational point of view, how much context to take into account is something we struggle with. I think a lot of NLP traditionally has focused on single sentence. So for example, machine translation right now, for the most part, is taking a single sentence and translating it. But that's the case where context could actually matter a lot. So knowing the genre, like Ashlee said, but even what the preceding paragraph was, things like that, you want to take it into account. And so NLP is moving a lot more in that direction.
There is one question about ethical issues. What would be to study ethical issues through NLP?
It might help me more, Maria Clara, to hear a little bit more about what you mean by ethical issues, but I'll give you some sense. If you're thinking about how companies think about ethics or behaving ethically, there are a few studies. I'm doing a study right now on CSR, corporate social responsibility, and how they reflect ethics and language in terms of different, talking about different topics here, really environment versus human rights, ethics versus some kind of employee type of ethics. Just mapping, do people mention those, and how do they talk? Do companies mention them, and how do they talk about them? What's the relationship between like kind of the field? How does the field of the company move in terms of discussing different topics of ethics, and how does that evolve over time? I mean, that's one thought, and I'm happy to send you some citations of people doing that. The other, I think, really interesting area for potential research is this area of brand activism. So there's a great JM paper, I think it might have won the JM award this year, about that kind of defines the construct of brand activism and makes a number of testable hypotheses on it. And there's a lot of future research that I think personally could come from using text analysis to study brand activism, looking at corporate claims and their effects on the world and all of that.
There is a quite long question here. Let me read it. I know that the topic is textual data, but I was thinking about studying internet culture, social media, and so on, and how most, if not all, textual data accompanies some sort of non-textual data, be it a meme, GIF, video, or the website design itself. I was wondering if the professors have ever worked at mixing textual and non-textual analysis, and how they did or would approach such analysis. Thank you for the great presentations.
Yeah, maybe I can take that. So yeah, we've definitely done a lot of work on understanding text in context of images. I think that's sort of the main thing we've been looking at. I think there's stuff to do with animated GIFs and memes and videos and stuff. And yeah, I think there are, that is definitely where NLP is headed. The kind of stuff that we've been looking at are things like when you have a Wikipedia article about someone and you have a photo or image associated with those articles, what's kind of going on there, right? Or you can think of, you have a product description, but you also have a product. And so suppose you're looking for, hey, I want like a red dress or something like that. Maybe that appears in the text, maybe that appears in the image, but you still want to be able to find those. So yeah, there are methods that try to combine both of that information, and they're surprisingly good, especially when more and more data is involved. I think sort of on the social media, there has been less work, but there has been some efforts. I think especially Ashlee brought up the misinformation and those kind of things a little earlier, and people are starting to look at how does misinformation spread, not just through text, but through the memes and GIFs and things like that, right? And there may be a lot of information that's hidden in other modalities than text. And how do we combine all of those things? So yeah, that's
cool.
Thanks.
Yeah, in terms of Lucas's question, hi Lucas, I know Lucas, it's nice to see you here. From a research design perspective, it's actually pretty straightforward, I think, which is it's another column in your data set. So, I showed you a typical data set. It's normally you'd have 4 out of 5 stars as an extra textual variable. The way I'm thinking you would incorporate it is to have just another column that represents whatever the whatever the image is. And of course, getting to what goes in that column is the part that Samir tackles with a nice algorithm to detect image type or whatever it is,
I will probably, this question will be probably for Samir. Thinking about generative models, Samir, like we have recent important transformers models that are being very impressive in terms of mimicking human beings in terms of generating text. And this will be a major application for management in general. What are your thoughts about this technology? Do you think this is gonna overcome human ability soon, or what is your impression? Because there are many possibilities of text generation, not only the text itself, but design issues or different ways of generating content. What are your thoughts on this area?
Yeah, that's a very good question. I think these generative models are definitely getting good at generating text that looks and reads like human written text. People have done experiments to show if you give human written text and machine generated text, people can often not tell them apart. And in some cases, they might even prefer machine generated text. But I think so, yeah, very promising direction. And I think it's one of those where the technology is so new that people haven't even like 10 years ago, we couldn't have imagined that this would be so good. So people weren't even thinking of potential applications really. But now that the technology is really good, I think there are lots and lots of applications in marketing, copywriting, all of these kind of things. And as to whether they are better than humans or not, it kind of depends on what your specific needs are. It's much more scalable. It can generate a lot of text. It can do some sort of variations, which might be creatively more interesting than what somebody who's sort of tired and you know, is trying to write formulaic like text. This can sort of give us nice variations. So yeah, I think there are definitely use cases there. I think the tricky thing with these systems, and I sort of hinted towards that at the end of my talk, is that they're not completely controllable yet. And you can't guarantee that the stuff that comes out is the kind of stuff you would want end users or customers to be looking at. And so right now, when people do use it, they always have a manual filter. So machine learning models generate the text and somebody edits it or whatever it is, or uses it as a tool when they're writing themselves. And that has been this partnership of NLP generated text and an editor seems to be what the next decade will probably look like, rather than something where it's completely generated text. I will also say that because these text generators are so good, it has become easier for spammers or anyone like that to write text that looks human and then just sort of flood comments. There are even YouTube videos that are completely automatically generated, where the text is generated by AI and then just go text to speech system, and then you just put some animation on it and things like that. And a lot of that will happen a lot more. And there may be areas in marketing where that is something to be aware of.
Thank you. I think I will address this question for both of you. There is a huge community in management, especially in marketing, that works with qualitative text analysis and still work manually doing like NVivo, using those kind of softwares that you have to do a lot of classification manually and things like that. Considering the state of the art of the field of NLP, is there still a reason to work manually with text classification? Would you recommend someone to still do manual classification?
I'm going to say yes. I mean, only because, well, I don't know. You know, I come from the tradition of content analysis, which is pretty accepted. It makes the review process a lot easier. I would say, no, do not waste your time on extensive coding, like managing coders. I wouldn't do that now, but there is definitely a role for reading the text yourself and understanding it at some point in the process. I'm not sure I would go all the way to using it exclusively, because the expectation now is to use a computer.
Yeah, I would agree with that. I think labeling text is not just to get labeled text in the end, but also be able to understand what's going on, maybe even change the definition of what you want to label in the first place, and understand a little bit more. So that exercise is still useful. What I will say is that there have been technologies that have been using NLP as a way to augment labeling as well. So you can say like, okay, I'm going to start labeling, I'm going to label a few, have an NLP system label more for me, and then look at those labels and revise something and label a few more, and sort of have them be an assistant in labeling as well. So yeah, I think there's still utility there. Yeah.
Great. Thank you, Samir. Thank you, Ashlee. I think Jonah had a schedule problem, so he asked us to shift the question and answers before his talk. I believe he's trying to enter in the room. I don't know if the organizer can help him.
I just asked the support to promote him as a panelist. They're gonna do this right away, Vinicius.
Okay, great. Okay, I think he will probably be in at any time soon, hopefully.
Yeah, no, probably. He'll join us in a few seconds.
Great.
Yeah, he's here.
Oh, great. There he is. Hi, Jonah.
Hi, guys. How are you?
Good, good. Thank you. Thank you for coming and finding the time to fit in your schedule.
Oh, no problem. Apologies. I'm in the middle of teaching, so things are a little bit busier than usual, but I'm glad to do it. And thanks for letting me in the room. I was sitting on the outside being like, I hope I'm not doing something wrong. So
thank you so much. The floor is yours, Jonah.
Fantastic. Great. I'm going to go ahead and share my screen. Give me just a second here. One second here. Great. Swap those views and share screen. Let's see if this works. Okay, great. Good. Can you guys see a customer service person or people?
Yep.
Fantastic. Given the wonderful panelists that have gone ahead of me, some of this may have been already covered, so apologies if it has been. But I'm going to talk a little bit about the world from my perspective, and apologies if it overlaps with some of the great things that have already been said. But imagine you call customer service and you have a problem. Maybe you missed a flight, maybe they canceled the flight, whatever it might be. You're talking to someone. Obviously, what you want to have happen if they canceled your flight is that they solve the problem. They give you some money back, they put you on a better flight. All of those are sort of the actual solutions they provide. But you could also ask, well, wait a second, beyond the sort of reward they give you or compensation they give you, might what they say and how they say it impact how satisfied you are with that interaction? And that's just one example of language, but we use language all the time for everything we do. And so what I'm going to talk about in this talk is kind of how we can parse language, whether it comes from customer service agents or others, both to understand the impact of language, so how what that agent says might impact you as a customer and how happy you are with the brand, and also what language reflects, what it tells us about the people, the brands, the organizations, and the cultures that create it. And so this is a talk on wisdom for words, or really kind of why you should use text analysis. And I enjoy giving these talks as time goes on, because we are seeing not only more and more work in text, but obviously more and more work on voice, more work on images, more and more work on video. I still think, at least so far, that we've been able to do a little bit more with text because we have a little bit better of understanding of how features of text link to outcomes. Anytime we're doing analysis of whether it's text, voice, and other things, we have feature extraction. So can we extract features reliably? And then can we link those features to the outcome? I think we're getting better and better in other modalities, whether it be voice, whether it be images, in extracting features from those things. I think that has improved a lot in the past few years. I still am not sure that we have an as good sense of what those features mean, at least particularly psychologically. We can know that there's a dog in an image, for example, but whether that dog is going to make the viewer happy or not is a different question. And so I still think we can do a lot more with text than we can do with those other things. And so that's where I'm going to focus today. But I think the same ideas or structure with which we can approach text can be used for these other types of often unstructured data when the technology gets a little bit better. And so in case we haven't met before, I'm Professor Jonah Berger. I'm a marketing professor at the Wharton School at the University of Pennsylvania. And I'm going to talk today a little bit about some of the work myself and my colleagues and great collaborators have been doing in this space, and kind of some things I think might be interesting or might be worth thinking about a little bit. So it goes without saying that there's a huge amount of text data out there. So there are online reviews, there are social media posts, there are text. But in addition to these very sort of recent and digital things, there's a lot of other stuff as well. There are customer service calls that we can transcribe. There are open-ended survey questions that we can analyze. There are firm annual reports. There are advertisements. There are newspaper articles. There are movie scripts. There are song lyrics. everything we do, almost everything we do, uses language. When we talk with other people, we use language to communicate. When we write anything, we use language to communicate. We use it when we are narrowcasting to just one other person. We use it when we are broadcasting to many people. Brands use language to communicate, whether in B2C or B2B context. Managers communicate with subordinates and colleagues through language. All of these things involve language. Even our thoughts are often occur through language, right? And so we can extract insight from any of these things. Any time in which there's language, it can be turned into text, and we can parse that for insight, right? To give you an example of thoughts, folks in the attitudes tradition, attitudes researchers, often ask people to do thought protocols. Write down what you thought while you heard this argument. Well, they're actually transcribing their thoughts, and we can parse those thoughts for insight. And so I think while we often think about text as a big data thing, it can be a big data thing, but it doesn't have to be a big data thing. You guys were talking about manual coding. Manual coding can be a great way on a small scale to parse data. If we're looking at millions of posts, it's going to be a little bit harder, but we don't always need necessarily millions of posts, and we don't always need the newest technology. I think different tools are good for different things. Some technologies are going to be really important for answering certain questions, but I think I want to point out that whether you're a behavioral researcher, a quant researcher, whether you're technically skilled or not, whether you come from an experimental tradition or more anthropological tradition, there's a lot of opportunities out here in almost every both topical area as well as sort of domain of expertise that you might be interested in. So there are many ways to extract insight here. And so one way to think about text data is essentially as behavioral residue. And so Sam Gosling at UT Austin talks a lot about sort of how we leave behavioral residue around, the artifacts we have, the things we own, the ways we decorate our room and offices. But we can think about language as the same thing, right? It leaves behind, in some sense, even a fingerprint of who we are. So Jamie Pennebaker and colleagues, as well as others, have done some nice work doing things like saying, hey, there's a play. Yeah, some people say Shakespeare wrote it. Other people say someone else wrote it. How do we know? Well, one way we know is we look at all the other plays that Shakespeare wrote and all these other people wrote and see whether the play in question is more similar to the ones that Shakespeare wrote or the ones that other people wrote. Because language provides a fingerprint. It's not only the types of things we talk about or the content, but also the style that we use to communicate with. And so particularly style can provide a fingerprint of somebody or something. And so the first thing, and I've mentioned this a little bit already, that text does is it reflects the individuals, organizations, and context that create them. Just like an individual might talk a certain way, an organization might talk a certain way. There's a nice working paper out there showing that organizations, when they get a female CEO, they tend to talk differently about women, for example. That's not an individual talking. The content is probably written by multiple people within that organization, but the organization, in some sense, seems to change based on the text within that organization is creating. Even context, think about cultures, right? The text created in American culture, let's say American children's books, may be very different than East Asian children's books. It's created by authors in those cultures, and so the cultural products that are made in those cultures reflect those cultural contexts in which they're created. And so just we can think about lots of examples of this, right? So self and other focus, easy thing, right? Am I talking about I or we? And that can tell us whether somebody is self or other focused, right? Is the person who created this text, let's say someone's writing something in an old project I did where we looked at broadcasting and narrowcasting. When I share with one person versus many people, am I focusing more on myself versus others? Well, let's look at the language you use. When I ask you to write an email to one person or 5 people, when I ask you to write a social media post to one individual versus a whole bunch of people, does it change how much you talk about I or we as an indication of who you're focused on? That's sort of at the individual level. At the cultural level, more recently, we have a project that hopefully will one day get published. I like it a lot, but it's had some challenges in the review process where we say, okay, people often say music is misogynist. it's sort of biased against women. Is that actually the case, and has it changed over time? And so what we try to do there is we try to say, okay, let's get 250,000 song lyrics over 60 years across a variety of musical genres, and let's look at how women and men are talked about and whether that changes over time. And what we see there is that it used to be quite biased. Males used to be talked about more competently than females. So think about warmth and competence. Women are often afforded warm characteristics, but not so often competent characteristics. Sure enough, in songs, you see that men are talked about more competently. It decreases over time, but it hasn't gone away. And in the last even 20, 25 years, it's actually sort of rebounded a little bit in the opposite direction. What does that tell us? Well, it's a lens into how culture is changing, right? Actually, these musical scores predict or seem to occur before changes in cultural attitudes towards women. We can't say causally that the music songs are causing changes in attitudes towards women, but they're at least a leading indicator of cultural attitudes towards gender, if not a causal driver of changes in those attitudes over time. And so we can say, hey, song lyrics reflect the culture in which they were produced. Beyond text reflecting, and I think text reflecting is great. I've done more impact work than reflecting work. I think reflecting work is interesting if you're interested in understanding individuals, organizations, or cultures, their changes over time. You're trying to say, you know, is somebody who wrote this young or old, male or female, biased towards a certain group or not? That's where I think reflect stuff is quite helpful, and it can be quite useful. But text also impacts the people that consume it. And by the way, sometimes it's not clear whether what you're looking at is reflects or impacts. So there's a paper I love in management where they show that employees whose language, they look at employee emails, they compare your language to your colleague's language, and they say that employees whose language is more different from their colleagues and doesn't sort of acclimate to their colleague's language over time are more likely to either get fired or have a negative work outcome, where folks that acclimate and stay acclimated are more likely to stick around. Is that impacts? Is that your language is changing how your colleagues feel about you? Or is that reflects? Your language is an indicator of who you are and your lack of cultural fit. Hard to say for sure, but we could certainly imagine looking deeper into that. And so when I say impacts, what we really mean is sort of influences the choices, attitudes, and behaviors of people who consume it. And Ashlee and I are both on a nice review paper in JM in 2020 that talks a lot about this distinction between text reflecting and text impacting. And so what this is saying is, hey, yes, text is a lens into who created it, but because it's consumed by others, most text is consumed by others, thoughts may not be, but most texts are consumed, it can also impact the audiences that consume it. And so let me give you a few examples of this. I'm going to mainly sample from projects I've worked on just because I know those better, but there's amazing, great work by Ashlee and many other people in marketing and management in this broader space. So this is just a recent paper with Grant Packard of mine where we look at language of customer service agents. This is actually experimental language. And what we do here is we vary the concreteness of language. So as you look at that bottom row, to the right is more concrete. I'll go search for that t-shirt in gray. To the left is less concrete. I'll go look for that, right? They're saying in some sense the same thing, I will help you, but they're using more or less concrete language. And what we find, and sorry, this is a lot going on in this picture, but what we find is customer satisfaction, that black line with the diamonds in it, increases when language is more concrete. And so does willingness to purchase. Sorry, willingness to purchase is the diamond. The black line is customer satisfaction, and the dotted line is listening. As language becomes more concrete, agent language becomes more concrete. Customers think that the agent is listening to them more, and as a result, they're more likely to buy from the brand and more satisfied with the interaction. And so there we could, on the other hand, say, what does concrete language tell us about the agent? But instead, we're looking at how it impacts the consumers of that content, in this case, a customer. And we can do similar things in a wide variety of domains. Right? So this is a paper Grant and I have in Psych Science a couple of years ago now, where we look at song lyrics and say, hey, why are some songs more successful? We find that songs that sing about you, so remember Whitney Houston's I Will Always Love You, for example. I remember that growing up in middle school. That was a staple of high school dances or middle school dances. When Whitney Houston sings I Will Always Love You, it turns out that songs with second person pronouns like you in them are more successful. It seems like language is having an impact. Songs that include second-person pronouns are people like them more, and they're more popular on the Billboard chart. Why might that be? Well, we do some experiments that show that when songs use second-person pronouns, you are more likely to think of someone in your own life that you might sing that song to. As a result, you feel more essentially connected to it, and you like it more as a result. And so they were using an individual word or set of words, a small set of dictionaries. Second-person pronouns are quite easy. Concreteness, we're using a much larger, more complex dictionary with many more words in it, but both of those are examples of using dictionaries to study impact. I'll give you just a couple other examples. We have another project. We look at written content online. We all read articles online, news articles, blog posts, other things. What leads to longer reads? Why do we read some articles and we read the whole thing, and others we read the first paragraph and opt out? Well, might the way that stuff is written shape whether or not we continue to read it? And so we have like 1 million page read events from, I think, 30,000 articles from, I don't know, some number of publishers. And we look at a whole bunch of different features. So everything from emotional features like positive emotion and specific emotions like anger, anxiety, and sadness, but also things like readability, parse tree height, familiarity, and concreteness. And so look at things that might impact the reader's likelihood of continuing to consume that article. The easier it is to read, for example, the sort of the lower the grade level, more likely I am to keep reading. Lower parse tree height, more likely keep reading. It's just easier to consume that content. Same with more familiar words or more concrete language. It's easier to keep consuming that content. And emotions may induce arousal or may also be associated with uncertainty. And those two factors also drive the likelihood of consuming content. I'm going to go through these sort of quickly. We have a paper in JCR recently where we look at emotional trajectories. So imagine you're watching a movie. Why do we like some movies more than others? Why are some stories more engaging? This is a sort of line of work that I and some colleagues have been working on recently. One feature we look at here is how the emotions change over time. You could call these sentiment trajectories or emotional trajectories. This, I think, is Star Wars. What we're doing is we're taking 500-word chunks of the movie. We're scoring them based on how positive or negative they are. We're plotting those scores over time, and then we're analyzing features of those trajectories. And so in this particular project, we're interested in emotional volatility, so sort of how bumpy the ride is, with the notion that bumpier rides can be more surprising or engaging, and as a result, you like the movie more. It gets higher ratings online, and you're more interested in watching movies that have scripts like that. And so again, there we're using a sentiment dictionary to help us construct features, then construct trajectories based on them to look at cultural products. And another project with Grant in psych science in music data, we look at atypicality. So we say, hey, how similar songs are to other songs shape their success? And I think this is a neat thing you can do with language. You can not only look at, hey, does it have certain features? Does a news article, a song, a movie have certain features? But also how similar is it to other things? And in this case, we look at how similar songs are to their genres. So we take topic modeling. We find the main topics across a set of 4,000 songs. We identify those topics. We measure the amount of those topics in each of the songs. And then we look at how different a song is from its genre. So what you see here, for example, is, songs tend to sing about things like street cred, spirituality, positivity, girls and cars, fiery love, family, and so on. Not surprisingly, hip hop tends to sing more about street cred. Rap sings more about street cred. Christian music sings more about spiritual. Country sings more about girls and cars. But any given song in those genres varies on these 10 dimensions. And we can calculate how different a song is from its genre. Its genre is all the songs in the genre averaged together. And we find that songs that are more different from their genre end up being more successful. And we show that's potentially because people like novelty when consuming content like this. And then in one of sort of extending the stuff I mentioned about stories, we have a recent project, it's not cited here, in PNAS with Olivier Tubia, where we take the same idea of emotional trajectories of narratives, but we say, well, let's actually look at the same thing, not with emotion, but just with content more generally. So you guys may be familiar with the idea of word embeddings, where you can place words in a multidimensional space. You can do the same thing with sentences or documents. And what we do, just like we did with that sentiment trajectory, is we can take chunks of a text, 500-word chunks, place them in a multidimensional content space, semantic space, a 300-dimensional space, and then look at the trajectory of a book, a movie, a television show, an academic paper, and look at how it changes over time. And we can extract features of that trajectory. We can see how fast a story moves. What do I mean by fast? Well, take 2 points of the narrative. If those points are further apart, point 1 and point 2, the further apart point 1 and point 2 are, the faster the narrative moved over that one period. And so across all the points in a narrative, we can calculate the speed. Smaller speed, lower speed is closer together, further speed is higher apart. We can also calculate the volume. What I mean by that, we'll take all those points, right? Imagine in a two-dimensional space, all the points could be close together or they could be far apart. Right? If I wanted to wrap a sphere around them in a three-dimensional space, right? The sphere would get larger the farther apart the points are, and smaller the closer together the points are. We can do the same thing in this 300-dimensional space. I can't, but Olivier Toubier can. And so figured out a way to sort of measure the volume of this space and look at the volume. Same with circuitousness. Right? So think about a clock, for example. The fastest way, or one of the fastest ways, I should say, around the clock is just to go in a circle. But you could also go 12 to 6 to 1 to 7 to 2 to 9, whatever it might be. You'd hit all the points, but you'd take a much more indirect route. And so we can calculate these features of lots of types of content, from movies and TV shows, but also academic papers and books, and we can say, hey, we can predict the success of the content based on the speed and volume of and circuitousness of that content. The neat thing is it's not the same across domains, right? So it's not that the same signature is always successful. It depends a little bit on the type of domain we're in, but I think that speaks to what these dimensions are helping us capture and how it changes how easily content is consumed. And so just to summarize some of what I just said, there's two big ways, I think, to think about and study language. One is language reflects. It indicates something about who created it. So if I say, oh my God, the new Batman movie was amazing, it reflects the personality of the person who wrote it, reflects their feeling towards the attitude object, the movie, and says something about the time in which it was created. But language also impacts, right? If I said, oh my God, the new Batman movie was amazing, it affects whether the people that I talk to on social media consume it. Service language shapes customer satisfaction, and song language shapes Billboard rankings. And folks have probably talked about this point already, but I think you can also think about using text for prediction or understanding, right? And I think lots of folks with a more quantitative bent have really focused on using text for prediction, right? Let's throw all the features, all the textual features we can into a model to get really accurate prediction. And I think that can be important. And there are times that is when we want what we want. I think in other cases, we care more about understanding, right? So if my goal, Oded Netzer has a nice paper on predicting loan default, right? Where we can get a really good accurate prediction of who's going to default on their loan, which is important for companies that are managing loan portfolios. But in other situations, I don't just care about prediction, I care about understanding. If I'm a customer service agent, I don't just want to predict satisfaction, that would be good, but I also want to improve satisfaction. And so understanding individual linguistic features that are linked to satisfaction will help us do that and do that more effectively. And so just in terms of some tools, and again, my colleagues who went ahead of me may have talked about some of this stuff already, there's lots of stuff out there, right? There's basic dictionaries like Linguistic Inquiry and Word Count that many people know, which I think is a great place to start. It's not the only place you want to think about. It's not the only place to end up, but it's an amazingly easy and accessible place to start. It gives you things like pronoun use and temporal focus and analytic versus narrative. Matt Rockledge has a nice dictionary called the Evaluative Lexicon. There are dictionaries out there about specific emotions, concreteness, familiarity, and a variety of others. I'll put a quick, I put a link at the beginning. I think it's textanalyzer.org is a website we built that has just some simple things you can extract from text there. Actually, if I was a better presenter, I would throw this in the chat, right? So give me 1 second. Let me, I don't know if I can multitask here. Give me 1 second. Let me see if I can do this. Well, I'll try to throw it in the chat, or maybe.
Jonah, if you want, I can do it.
That would be great. Thank you. I'm not smart enough and fast enough to do both of those things. So I think it's textanalyzer.org. But if not, you'll probably quickly find out because I'll tell you it's the wrong place. I talked a little about topic modeling. So in that project with Grant on music, for example, we first extracted the key topics or themes of the songs and then did some work with those features. I love topic modeling. I often use LDA. It has some downsides, but it's great for sort of getting a sense of what people are talking about. It's also great for controls, right? If you just want to control for a variety of things, in some projects, for example, we just want to control for the topic. Oh, thank you so much. Appreciate it. We just want to control for the topics that people are talking about, not because we're interested in them, but that may impact things. So in the concreteness project, we want to control for what the customer service agent talks about. We can use topic modeling to do that. Word embeddings, also a great tool. I've used them more not for individual words, though that sometimes, in that music project with misogyny, but also things like document embeddings, or sentence embeddings to get larger cultural items or distance and relation between things. And then there's more complicated neural network language models like GPT-2 or 3, whatever we're at the moment, that can even produce text by understanding things about language. And so those, I think, give you really, really precise prediction if that's what you're interested in. Just to wrap up, I think, text analysis can help any research topic. That's one reason I think it's so powerful, whether you study attitudes, emotion, goals and emotion, decision-making, goals and motivation. Any of these things can be looked at with text analysis. And I think whatever area you work in, you at some level are working with text. Unless all you're doing is getting people to answer survey items, the text of those survey items may impact their responses. We have a project at the moment where we're looking at past versus present tense, where we show that different tenses in language can impact how persuasive content is. We have another project looking at hedges, how hedge language might affect persuasion. So we need to think about using language with our scale items. If all you're doing is scale items, you're probably text analysis is less useful. But even if you're asking people to write things, right? You can ask people to write something and then parse that for insight. You might not know what you're looking for initially, but I think particularly tools like Luke allow you, and some of what Text Analyzer is doing, allow you to get a lot of features quickly, which can be good early on in the research process for getting a sense of directionality. And so why text? I think there's a lot of good reasons. You might have concerns about external validity. Well, great. Let's move beyond experiments and let's go to the field. You might have a desire to study real behavior. Great. That's tough to do at scale. Let's use text to get at that. I also love the ability of text to look back in time. Right? It's hard to do a survey going back in time, but text allows you to do that. Replication crisis is out there. People are wondering, do studies replicate? Do they have real effects in the field? Text helps us with that. Issues with self-report, text helps us with that as well. And so I think I would ask, just to sort of close, I think I have maybe one or two more slides, but what questions do you want to answer and how can text help? And what data could text analysis help you parse? And I think the answer is hopefully a lot of things. Text is the future, as is images and videos. I think it's the future of behavioral science. I think it opens up a lot of doors. And so I hope if you're not already using it, you please do. Here's some great resources out there. There's the paper that Ashlee and I and some other great colleagues are on from JM from a couple of years ago. There's a conference we host at Wharton. We haven't hosted it recently because of COVID, but we'll hopefully host it again, all about behavioral insights from text. There's this text analysis tool, textanalyzer.org. Ashlee also has a great review paper in JCR, I think in 2018. Grant Packard and I have a paper coming out in American Psychologist that's a review paper on sort of using text analysis to understand people and culture. And so all of those are great places to start. Thank you guys so much. I think I have like 3 minutes, so I'm happy to take a couple questions if there are any, but otherwise, thank you guys. Appreciate it.
Thank you so much, Jonah. Thank you. I believe that, let me just check here in the chat. No. Jonah, thank you so much for taking the time. We know how busy all of you guys are. I think we are short on time, but I'd like to thank you, Sandro, for the invitation for this session. Thank you for the audience to be here, and most importantly, thank you a lot, Ashlee, Jonah, and Samir, for taking the time for sharing your great knowledge on language with us. And I would say that not everything about COVID is bad. So we had having this opportunity to have such a special team of world-class researchers on language is a great honor. And we were happy to learn from you. Thank you so much for the opportunity.
Awesome. Thanks, guys. Have a great rest of your day.
Of course, my pleasure.
Yeah, thank you for inviting.
Thank you, everyone.
Bye.